Hi guys, in this video I'll talk about work energy theorem, how it is applied and what does it physical means. Okay, work done by all the forces is equal to change in kinetic energy of the system. This says work done by all the forces is nothing but change in kinetic energy of the system. By all the forces we means conservative as well as non-conservative. We can also divide the forces as external and internal. So work done by all is work done by conservative plus work done by non-conservative. Again, we can also divide forces or categorize or classify forces in terms of external and internal forces. So it will be work done by external plus work done by internal forces, which is equal to final kinetic energy minus initial kinetic energy. This can also be termed as change in kinetic energy. Okay, so now we know one more definition, that work done by conservative forces is change in potential energy with a minus sign. Okay, so we just put minus delta U is change in potential energy with a minus sign, plus work done by non-conservative forces is delta K. So we have work done by non-conservative as delta Ke plus delta U, which is mechanical energy change. Kinetic plus potential is mechanical energy, and sum of their changes is change in mechanical energy. Okay, so mechanical energy is nothing but sum of Ke and potential energy. This is the basis of work energy theorem. If work done by non-conservative forces are 0, okay, if this is 0, we can say change in mechanical energy will be 0. So we can say there will be, if there is some loss in Ke, there will be equal gain in potential energy, or vice versa. If there is some gain in kinetic energy, there will be equal loss in potential energy, provided no work is done by non-conservative forces. They may act, but they should not perform any work. Okay, mark my words very carefully. Every word I'm saying is very important. Okay, so on disturbing slightly from position A, the rod moves and the particle reaches point B and point C. This is the rod hinged at O. Okay, this is hinged at O. So find VA and VB. The rod is light rod. So we can say the only force which is doing some work is mg, and that is conservative. So no non-conservative force is doing some work. We can say loss and gain principle will be valid. So what kind of energy is losing? Loss in PE from A to B. A to B की बात करते हैं. So loss in U is equal to gain in K. What is loss in U? mg L. L height नीचे आ गया. The height difference is L. And what is gain in kinetic energy? Half m VB square minus 0 square. Velocity at A is 0. So what is VB? Is simply under root 2GL. Similarly, A to C, we can say the loss in potential energy is mg into 2L. The height difference from this point to this point is 2L. So half m VC square minus VA square, which is 0. So VC is nothing but 2 root GL. Okay, so these are the velocities at A, C. This is a very famous question. When the block is released from the position of natural length of spring, we have to find the maximum velocity and the maximum elongation in the spring. Okay, so let's say first of all we'll calculate the maximum elongation. This is the maximum elongation up to which spring will move. So reaching here, you can say, reaching here, the velocity of the block will become 0 and the initial velocity is also 0. So what kind of loss and gain are taking place? Loss in GP, gravitational potential energy, is basically converted to gain in EP, elastic potential energy. So by this statement I can write mg x max is half k x max square minus 0 square. Okay, so we can use this equation to find x max as 2 how much x max will cancel, so 2 mg by k. It is very interesting to find that at this acceleration is not 0. In fact, acceleration is g upward, because the force acting at this point will be kx and mg. Kx will be how much? 2 mg. So the net upward force will be this mg, and it will provide you an acceleration g. The position of equilibrium will be at exactly mid. Acceleration is 0 at this point. I can calculate the position of equilibrium. For equilibrium, I'll say k into x will balance mg. So x equilibrium is mg by k, which is x max by 2 also. X max is 2 mg by k, so mg by k is nothing but half of this. So this is the position of equilibrium, and I can say at equilibrium velocity will be maximum. Okay, from here to here, speeding up, and from this point to this point, slowing down. Okay, this type of motion is taking place. So what is Vmax at this point? So I should name from initial to equilibrium. I'll again use conservation of principle. Loss in GPE is converting to gain in two energies. One is EPE, another is KE. So what I'll write, mg x equilibrium, which is mg by k, is equal to, this is the loss of GP, gain in EP is half k x equilibrium square, which is mg by k square, plus half m V max square. V max square. This is the maximum velocity which is at equilibrium. From this equation I can easily get Vmax as, just calculate, you will get half will cancel, and Vmax will be m will cancel under root, how much? 1 m will cancel, will have g square mg square by k. This is the Vmax. In the next problem, again similar problem is there. When the system is released from natural position of natural length of spring, we have to find maximum velocity and x max. For x max, simply convert loss in GP of this is gain in EP of the spring. So mg x max, let's say it falls by x max and stops. Okay, so this is x max. So mg x max is the loss in PE is half k x max square. Again x max will come out to be similar, which is 2 mg by k. What about Vmax? Vmax will again appear at equilibrium, just equal to 0. But remember this time the kinetic energy will be given to the total mass, which is 2m. So this is Vmax. So I'll write loss in PE, mg x equilibrium. X equilibrium is again how much? mg by k is x equilibrium. So mg into this x equilibrium, mg by k, is loss in potential energy. Gain in elastic potential energy is half k x equilibrium square mg by k square plus half m. This is 2m. Again, this is the only critical point where you can make mistake. 2m Vmax square. Both the objects must be moving with the same velocity. So the kinetic energy will be half into the total mass which is moving into Vmax square. So Vmax will come out to be nothing but root 1 by root 2 times of the previous value, which is under root mg square by 2k. Okay, enjoy.